Hi, Julian here from PopcornFX. In this video I'm going to take the dust motes effect we made in the previous video and show you how to make it a little bit prettier and how to add speed lines when we move the camera or when the particles move fast, falling down, for example, for rain. So here I will go inside this layer. And the first easiest thing to test with is just to make the particles fall down. So I will try with a initial velocity of minus scene axis up. So now they all fall down. I'll actually make this faster, minus 6. So now they're falling down quickly. And here in the billboard node, it has a billboarding mode property which defaults to screen aligned, and I can pick that to be axis aligned, one of the axis aligned modes. So I'll just pick the first one, axis aligned. And here I have an axis pin which appears, and if I wire in velocity, I will now have extremely stretched billboards with ugly endpoints. That's because they intersect the camera plane. So typically when you want to make such billboard stretching, you want to do that to fake a motion blur. So to fake motion blur, it's never the actual velocity in meters per second that you wire in the axis. You actually would need to divide that by the shutter rate of your camera. So here I'm going to approximate that by multiplying it to a small value, let's say 0.016. which would give basically 60 FPS shutter rate. So if I slow down the speed, you can see that that stretching isn't very nice when I have the particles around the camera. If I switch to wireframe by hitting F3, you can also switch to wireframe using this drop down here. So if I hit F3 and move the view around, you can see how the quads are stretched and rotate around the view. That's where the other billboard modes come in. So if you use axis aligned spheroid, they will actually approximate a spheroid, and you will never see that plane purely from the side. So it gives a much better result. They still intersect with the camera plane. That's something we can address separately. And the last mode is axis aligned capsule, which might be actually much better for to fake motion blur, except it's slightly more expensive because it has more geometry. Instead of a single quad, we have 2 quads that make up the particle. But I'll keep that rendering for now. So here we do have the stretch very easily based on the particle velocity, but when I move the camera around, I have 0 feedback of the camera move speed, and because the particles are all moving very fast, I just have the impression that this is a purely screen space effect. So to do that, to change that, I will change the velocity of the particles that I wire into the billboarding axis and actually subtract the view velocity from it. So in 2.6 there is no view velocity node. There is a view velocity accessible from scripts, but I'll show you another way to compute the velocity of whatever value you have. So here I'm going to take the view position, set this to evolve so that it evaluates every frame. And if I want the view velocity from the view position, there is actually a node that gives me just that. You wire in a value and it tells you how fast it changes per second. And this is the dxdt node, which is a derivative node based on time, and the derivative of the position based on time is the velocity. So here, if I wire that in, this gives me the actual camera velocity. So let's wire the rand back in to have, so because this is evaluated at spawn, you have to wait for the particles to respawn to see the change. That's why it doesn't instantly change. One thing you can do is click on the timeline, go to a place that you're happy with, and now if you change that, you will have the viewport instantly change. But when the simulation is running, you will have to wait for it to respawn. Or hit Ctrl R. So now I can see that as I move around, I do have the particles that stretch based on where my camera is going. So now there is something slightly nasty about that, is that, as you can see, the faster I move, the longer they become, and the brighter overall the screen becomes. This will be much more obvious if I bump the particle count up, and if I bump the brightness down. Oh, so yeah, I'll quickly multiply that brightness value by a smaller value, say 0.3. And put even more particles. Alright, so here I have 125,000 particles, and you can clearly see the high difference of brightness as I move around. Here the screen is dark gray, here it's almost white. So what I want to do here is to actually scale the color of the particles, to scale the intensity based on how much they get stretched by the velocity vector, by the billboarding vector axis. And this is actually a natural thing, because if you think about it, when the particles don't move, the screen area taken by the dust mote is much smaller than when they are stretched by motion blur. So when they are stretched, the overall intensity is decreased. Well, the overall intensity has to be kept, but the intensity of each pixel, because the area the particle is drawn on gets larger as it gets stretched, has to be smaller. So here to do that, I am going to use a script node. And I will expose an input named velocity. I will rename that one. No, I will keep it as value, except I'll switch it to be a float in the output. Oh, I'll switch it to auto, actually. So now if I go in there, what I want to compute is the difference between the area at rest of the billboard and the stretched area. So I actually also need to have the size I'm rendering with. So here I am going to pull that out to add a size input. Wire that in. And now in my script, so I can compute the rest area. So the rest area is the width times the height. So as the size is the actual radius of the billboard, the width is twice the size, and the rest area is width times width. Quick note, you can hit Control Enter in the script to validate what you've typed. It won't save the effect. You can also hit Control S to save the script, but it will also save the effect. Actually, it will save the effect and therefore save the script. But if you just want to apply the changes without saving, you just hit Control Enter. And the little star here, meaning it has pending changes, will disappear. So let's say I type value equals, let's say 0.1. Here, if I hit Control Enter, the viewport updates because now it takes into account that override I just made. So this is my rest area, and now I want to compute the stretched area. So the way the capsule aligned billboarding works is that actually I'll put back in the velocity so we can see better. I will pause the viewport. Oh, there are too many particles now, hard to see anything. Yep, I will reduce the spawn count. Reset. Right. So the way they work, this one is perfect. So the way they work, this is the length of the stretch axis, and here on top of it you have the radius again. So the width here is twice the radius, and the height is actually the length of the stretch axis plus twice the radius. So if I go back to my script, I'll write just that. Rest radius equals the length of my velocity plus the width. Sorry, hard to write with the mic on the way. And the, oh no, it's not the rest radius at all, it's the height, it's the stretched height. And now I have the stretch area, which is the width times the stretched height, right? And now the value of my final intensity is actually the ratio of the rest area over the stretched area. So the bigger the stretched area becomes, the lower my final intensity will be. And I'm actually going to multiply the input value. So here I can write times equal, or just value equals value times this. I'll just write times equal. Right. So now, when I move faster and faster, the intensity decreases, and I keep an overall similar on-screen intensity for the dust motes. Very quick change before wrapping up. I actually don't like the way they are popping, so I will add a fade over time. Multiply the intensity with that. And change this for, let's say, so to insert new points in the curve, you can hit Alt Shift and click, and it will insert a point under the cursor, or you can hit Alt and click and it will insert the point where the line intersects the curve. So here, Alt click, and it will preserve the tangents. Here I don't want any of that, just a flat curve. I'll set that to 1. And now I have my particles fading in and out instead of popping, which is much better. So that's it for this video. I hope you liked it. Stay tuned for more improvements of this dust mote effect, where we'll see how to reuse that behavior, make a generic template out of it, and use it for other camera style effects such as rain or snow or other effects. Thanks for watching.